All right, starting off with SI, you guys know you get extra credit. And in order to get extra credit, all I need to do is have your name that you have on Cabrillo as your Zoom name. And that is all of that. It looks like both of you have that. So very, very nice. Thank you. And those who are watching the recording, you can just send me that you watched it if you want the credit. If you don't want the credit, you don't have to tell me anything. All right. Starting off with debugging, there are two types of coding errors that we can encounter. The first one is the easiest to solve. It is a syntax error. A syntax error is an error in the way that the code is actually formatted itself, like how you decided to write the language. That is a syntax error. A logic error, on the other hand, is when you as the programmer write something that's not actually as you wanted it to be. So say that we wanted to add two numbers and instead of adding, we subtracted them. So these are harder to find because the compiler will not alert you of them. That is the overview of the two types of errors. Now we're going to look at a code that I wrote that is very, very badly messed up, as you can see. And we're going to talk about how would you go about debugging this program if you ever encountered something like this. So first of all, we wrote the program here. When we were writing it originally, it would have been better to compile it frequently so we don't have as many errors, but we are here now and we have a lot of errors and we are going to look through how you can solve these. So firstly, we can compile. So who remembers how do we compile a program? So if I want to compile this debug.cpp, what would I type in my terminal? Alrighty, this would be G++, because that's the compiler name, followed by the file that we want to compile, and that is debug.cpp. There we go. And it came back with, as expected, a lot of errors. So how we look at errors is very important. And especially when you have a program that has so many errors like this one, it can be overwhelming if you have like a whole bunch of them. It actually didn't give us all the errors in the program, but I'm going to show you how to look at these. So firstly, when we are looking at errors, it's always important to look at the very first error on the list. So namespace name. And one thing to notice about these errors is these numbers that they start with right here. It says 2:17. Can anyone guess what that refers to? Here, I'll give you a hint. The 2 refers to the line number. And if we look at our program over here, this matches up. We can see line 2, and that we do have an error on line 2 that happens to actually be what it's saying. It's saying unexpected namespace error, and it says using namespace standard. It even gave us like a little caret that's pointing at what we did wrong. So now we can go look at this and we can fix it. So it's not namespace standard, it's the shortened version, which is namespace std. And now that I fixed one error, I'm going to save it and recompile. And now it gave us a new set of errors. All right, so we always look at the very first error first, and that is this one right here. And we start off by looking at what line is it on. That's always a good thing to start. So this one is on line 1, and it's saying expected file name or file name. File name, one of them is in quotes and one of them is in brackets. Who can tell me what is wrong with line number 1? What do we think? This should be parentheses. All right, let's give it a shot. So now we tried to fix the error. So I'm going to save it. Nope, I need to save this guy. Save that and recompile. And it is still there. It's saying, hey, it's even giving us a pointer at the parentheses that says something's wrong with those parentheses. Let's take a closer look at these, at the error. It says the file name, which is IOStream, should be either in quotes or in brackets. So we know it's going to be one of those two. So we can try both. What do you want to try first? Quotes or brackets? What sounds better? Brackets, nice. So when we include a file or a library in our program, the standard is when we are just like including a library, that's like a standard of C++, we use the angle brackets, and IOStream is a standard library. So angle brackets, and then we are going to save the program and recompile. Okay, there we go. So the next error we see is on line 6, and it says expected unqualified ID. Okay, so this is, yeah, there we go. Nice one, James. I want to remove the 1 in front of day. And the reason being, when we create a variable, its identifier or name has to start with either a alphabetical character or an underscore. So a number in the front would disobey those rules, and the compiler is complaining about it. All right, so saving the file, recompiling. Okay, it says expected semicolon at the end of declaration. This one was nice and easy for us. So C++ statements end with a semicolon. So that one's a nice, easy fix there. So I'll recompile. And next, it says expected semicolon at the end of declaration, this one. So we can put that one in. And notice how I'm fixing one error and then going back and recompiling to make sure everything that I did is working correctly. Okay, another way to look for errors, because the terminal is not cooperating with me at the very moment, is to look on the text editor. It actually highlighted a few lines in red for me. And this is very nice because it's telling me, hey, line 7, I kind of think that there's something wrong. You might want to go check it out. So what else on line 7 looks incorrect while I try and figure out what's up with the terminal? All right, this one's a little bit of a tricky one. So in the beginning of line 7, I specified that the data type for my variable month is going to be a character. And a character data type is one that we haven't talked about too much, so I'll review it really quickly with you guys. A character data type is a data type which can store one character. And characters are like things on your keyboard, like A, B, C, 9, exclamation mark, question mark, that type of stuff. But the very important part to this is it's 1. And if you see right here, the data that I'm assigning to month is 2 characters. So what data type do you guys know of that would be a better fit to hold 2 characters or 2 numbers? What would that be? Remove the, yes, that's a good start. Very nice. So now it would be an integer, and we got to update the data type as well. So we'd say int month is assigned with 02, and that should fix that up. So we just changed it from no longer being a character, and we removed the single quotes and made it an assignment statement. All right, so if the compiler is going to cooperate, we could actually do some more debugging here. Okay, we'll take a look at this one next. This one looks relevant to us because it says on line 9, we're going to take a look at an error, and it is specifying that the error is with the cout statement, and it's pointing at these insertion operators. So we're going to look at line 9, and sometimes the point, like the little arrow, is helpful, and other times it's not. All right, James, you got one of them. So we're going to switch this to endl because that stands for end line. All right, what else do we see with the cout statement? Exactly, C++ statements end with a semicolon. Now I'm going to reboot the terminal because it's too big and I can't tell what's going on. Okay, that might have been the problem. It wasn't saving. We are expected a semicolon after the expression, but we just added one of those. So something else is wrong here, and the error is not being very indicative of what that is. And sometimes this happens, and it's one of the most frustrating things in programming, but we at least know that the error is on line 9. That we are pretty sure with because we corrected all the errors above it, and line 9 is saying that there's an error. So we can take a look at our code. All right, so we have cout statement. What do you guys think about these two characters right here? What do we think? It's even underlining them for us. Yeah, it's going the wrong direction. We got to put them going this way for a cout statement. It's called the insertion operator, and it always points in this direction for a cout statement. All right, cool. And save if it works this time. Oh, there we go. Clear errors. We are expecting a curly brace on line 12. Well, that makes perfect sense because at the start of main, we start with a curly brace, and to end the program, we have to end with a curly brace. Very nice. All right, so that looks good to me. I'm going to save it again, compile, and look at that. No errors, nothing happened. And this is the best sign in programming. When we compile the program and we return with the command prompt, that means that there were no errors in the program and it worked and we got an executable. So we can list files to see the executable. It's right there, a.out. So we can compile, or we can run it by doing a.out. And the date today is that. This is an old one from the last SI session, which is why the date is very old, but everything worked as expected and we got rid of all the bugs, even if it took a little while and the compiler was not being cooperative. So do you guys have any questions on debugging? Hopefully that helped a little bit for when you guys get bugs in your program, because they are inevitable. It is very, very, very rare that you'll ever write a program without problems. And some tips on how to avoid bugs in the future is do not write the program in all one go like I just did. That was just an example. But you're going to write it in small increments. It's actually called incremental development. So you'll write a little piece of code and then you'll compile it, make sure everything comes back good, and then you'll keep adding to that. When an error message does come up when you are compiling your code, you're going to have to address it because it's not going to magically go away. And go back to your resources. So you can always contact me through Discord or email if you're having a bug that you can't figure out. I know Steve has office hours, and your textbook Zybooks is also a good resource when you get better acquainted with that. It's going to help you out on the exact definitions of some things. And as always, practice. Practice is what's going to get you good at programming. Okay, so we are going to quickly talk about input statements just to make sure you guys know what they are. So that way we can start doing math stuff. So input statements kind of looks like a cout statement. And instead of writing cout, we write cin. This stands for characters in. In. And notice that the little carets are going the other direction. So for cout, we write C and they go this way. For cin, they go the other way. And if you mix those up, as we just saw, that does create an error. And this input statement takes input from the console, from the user, and whatever they input is going to get stored in the variable that you specify right here. So the syntax is the word cin, followed by these operators right here, and then whatever variable you want to take input for. I know Steve went over those in class, so I don't want to go in too much depth about that, but does anyone have questions about input statements before we go into some other stuff? All right, always interrupt me if something is confusing. All right, so math and C++. Math and programming is actually pretty important. You don't have to know a high level of math for this class at all, so do not worry. But I do want to talk about some basic arithmetic that you can do in C++. And the good thing is that it's actually pretty standard compared to the operators that you are used to. So in C++, addition is just a plus. Subtraction is the minus symbol. Division is the slash, which is pretty standard. Multiplication is where things get a little bit different. It is this star character, and this goes in between the two numbers or variables that you want to multiply. And it's important to note that AB does not multiply like it does in math. Neither does A times B or the parenthesis thing in math. That does not work in C++. So if you're ever doing multiplication, you got to remember to use this symbol right here. You do need to put the multiplication sign outside the parentheses. It does not work like this. So nice job, James. And parentheses also follow the same rules that they do in math. So if you want something to happen first, parentheses go around it. And one last operator that you might not be too familiar with is this one called modulo. And it's actually a pretty powerful thing that we do use semi-frequently. And what it does is when you are dividing two numbers, if you do it on a calculator, you're going to get even division. Everything is going to just go into decimals. However, if you do the modulo operator, what it does is take in two numbers, it will get the remainder. So let's say that we have 25 and 4. Yeah, I think this works. So if we go all the way back to grade school and we look at your long division, we know that 4 goes into 25 how many times? Well, 6, right? 6 and 24. And then we would subtract this and we get a remainder of 1. Well, if we were doing this on a calculator, you would get a decimal answer. You get 6 point something. However, this remainder is actually what we can get using the modulo operator. So if we did 25 modulo 4, this would result in 1. So modulo is used to get the remainder. And the rest of them function exactly the same as they would in regular math, except for division. One quick thing to touch on. All right, I will do a quick recap. So when we create variables, you guys might remember that we have to define a data type. So when we create a variable, we might say int number is assigned with blank, or int num, or double my number, like stuff like that. Stuff like this. We have to define a data type. And this data type actually is really important depending on what you want to do with the math. And when we have two integers that divide each other, so like 1 and 2, this is going to perform something that we call integer division. And integer division does not involve decimals. Remember, we have a data type here that specifies ints, and ints can only hold whole numbers. So what happens is when you have a division problem, which would go into decimals, let me give you a better example here than this. Let's just say 7 divided by 2. Well, if we were to do this on a calculator, 7 divided by 2 would give us 3.5. However, since this is an int and this is an int, whole numbers, it actually gives us in programming 3. And the reason is an int cannot store anything with a decimal point, so it just drops that. If we did want to get 3.5, we'd have to do 7.0 divided by 2.0. Then it would give us 3.5. So that's an important thing to note if you're ever getting a division problem where you're expecting a decimal and you aren't getting it. The reason is the values that you are dividing are integers, and you have to make those a float or a double. They have to be something that involves a decimal point, otherwise the computer cannot store it. Okay, that was a lot. We are going to go into actual programming now. So we are going to create a calculator. And the idea here is that the user is going to input two numbers. And then we are going to program a code which will calculate the sum of those two numbers, the difference of those two numbers, the product and the quotient. And then we will output that back. So it's a little simple calculator, but it involves a lot of skills that we have learned, and hopefully that will be fun. All right, so I am going to come over here and we are going to create a new file. So I'm going to open my text editor, and I'm going to firstly name this something that ends in CPP. I'll just call it calculator .cpp. And the reason we're doing .cpp is that way the computer knows that this is a C++ file. That's what CPP stands for. And I will save that. All right, so now, what is the basic structure that all programs start with? If I'm going to write any program, what is the basic structure that I need to put here first in C++?
Hashtag include IO stream,
Perfect.
but like with the little side V's, greater than, less than.
Perfect. Nailed it. So this allows for input and output in our program. And if you remember the description, we're saying that we're going to input some numbers and we're also going to output some numbers. So that is our very first step. Very nice job. What is the other thing that we have to write on the second line that also allows for input and output?
Well, since like we're planning on making it a calculator, like do we also just like include CMath?
We are going to look at CMath stuff a little bit later on.
Oh, okay.
We're going to write a program for the quadratic formula, but this one we're just doing basic arithmetic. And basic arithmetic is a standard feature of C++, but very nice job. We're going to look at that a little later. All right, I will let you guys know it's using namespace standard. And this is just something you're going to write with every single one of your programs. It's something that we go on to talk about more later on in the semester, but all you need to know right now is it allows us to use input and output. Okay, so now what happens next? Can I just start writing code now, or do I have to do something else?
Yeah, you got to put like int main with the 2 parentheses and the bracket.
Perfect. All right, so all
bracket.
of our code is going to go in this little box we call function, and the function is called int main. Every single one of your programs are going to have this function, and it will always look like this. It says int main, little parentheses, and then all of your code goes inside of these curly braces. All right, so we can't write code out here. This is no code, and no code up here. All of it goes inside of the braces. Perfect. All right, so now let's take a look at our instructions again. So our instructions say that we are going to ask the user to enter a number and then enter another number. So how do you think I could achieve this? How could I take this input along with those prompts? What do you think I could do to make this happen in code? Well, we know for starters that we're taking input from the user, which means that we're going to need to write a cin statement. We're going to need to write characters in the statement. And we can write cin, but we have to have a variable here to put that stuff. We can't just like take information with nowhere to put it. So we need to create a variable which we can use to store the information that the user enters. And the user is going to be entering numbers. So what data type do you think that my variable should be?
Int.
Int, awesome. And I'll just call it A. Make it nice and simple. And now we're going to say characters in, we're going to take input for A. That's simple. All right. And we actually want, I'll run this real quick so you can see what happens. I call this calc. I need to go to desktop. And now I'm going to make sure we compile G++, and I call this calculator.cpp.
Oh, well, it doesn't have like the return 0 and then the end bracket. Well, I mean, it doesn't have return 0, right?
It doesn't have return 0, but normally stuff compiles without return 0. It's a weird thing. Let me make sure this is saved. And if not, we will use something else to compile this. Okay, amazing. Good job. It is compiled for me before without return 0. Apparently, it is actually very important. So I learned something new today too. All right, very cool. Good job. You get extra points from me. Okay. Very nice job. And now let's just make sure this all compiles still. Perfect. Okay. So we have a program here that has compiled. And what it's going to do is going to ask for input from the user. And to see that, we're going to do a dot out. And notice here, it's just like waiting. It's not doing anything. And it's actually waiting for input from the user right now, but it's kind of hard for us to tell that. And like I could enter 7, and now it's going to continue because it took that input, but it's not very descriptive or user-friendly. So what we're actually going to do here is write something called an input prompt. And what this is just a little cout statement before we take input that tells the user, hey, it's time to put some input. Can you please do that? And it's just a little message that makes it more user-friendly. So I'm going to write that. So cout. And this is just a little message part. And we could say enter a number. All right. And now I'm going to save this, recompile, and rerun it. And now it's saying enter a number. This is a lot more user-friendly. We can enter a 7. So we are partially there. All right, so now in the instructions, it tells us enter a number. Then we also have to enter another number. So how do you think I can achieve this second step? So I'm also repeated the first, but I want you guys to tell me. I need to take input for one more number from the user. Okay, well, we know that we're taking input, so we need a cin statement. And what do you guys think? Should I use a again, or should I create another variable?
Another variable.
Yeah, very nice. And the reason is if we were to take input for a, what would happen is the new input that the user enters would just overwrite the previous one, and we would never see that input again. So we actually want 2 separate variables. So we can take input for a and have that be on its own, and then also input for b. So we're going to say cin, we're going to take input for a, then input for b, and I'll make a little prompt here. Another number. All right, perfect. So we have completed step 1. We are taking input for 2 numbers. All right, step 2 says that we need to calculate the sum, the difference, the quotient, and the product of these 2 numbers and output that information. So a little bit of backtracking here. When we do arithmetic in C++, we use those operators that I previously talked about, but there's a way that we have to format this stuff. And there's 2 possible ways that we can output this information. So the first way is to directly output the result in a cout statement. So I could say cout, then I can have my expression right here and just output it to the console. Or another thing that I could do is I could create a variable which could hold the result of the expression. And then I could say the expression is going to get assigned to this variable, which is going to hold the result. And then I could just output that end result. So benefits and disadvantages to each. The benefit of this one is it's short. It's all just in the cout statement. But the disadvantages are, number 1, the cout statement could get pretty long if you're going to have a long equation here. And number 2, as soon as you make this calculation and print it out to the console, you'll never see it again. It's not being stored anywhere. The only time that we are actually storing something is when we use an assignment statement. That's when stuff is getting stored. That's when stuff is getting saved, and we can use it again later. But if you're never going to reuse a calculation again, this is an option. So now knowing this, how could I compute the sum of A and B and then output it to the console? And which of the 2 methods do you think would be best? There's no actually correct answer here. Just which one do you want to do? You know what? To get a little bit of experience, we can do a little bit of both. We can do some of these that are going to be in a cout statement and some that are going to be assigned to variables so that we can get a little bit more experience. So I'm going to start with assigning it to a variable. So I'm going to just create a variable. I'll say int sum. And then I'm going to say sum is going to be assigned with, and I need to create an expression here. And my expression is going to be the sum of A and B. So put in chat, how would you write that in code? Well, luckily for us, it's very similar to math, and it's just A plus B and a semicolon. That's it. And generally, we do put spaces around the operator to make it look cleaner, but it's just a style thing. All right, very nice job. I see you guys both got it. Joe, just so you know, I think it's probably an auto capitalization thing on your computer, but a capital A is different than a lowercase a. If I were to run this, not, I didn't save it. That would be why. It's going to say undeclared identifier A. So C++ is a case sensitive language. So if you have variables which have different cases, they're actually completely different variables. So A is different than capital A. And if we recompile that again, we can just make sure everything, whoop, type X, oh, that would be right there. There we go, no errors. All right, so now we have A plus B is stored in the variable sum. And now I want to output sum. So I'm gonna just do cout statement. And I stuck an end line after that. All right, so now I'm going to save and recompile. And run the program, enter a number 4, another number 7. And 4 plus 7 is indeed 11. And if we wanted to make this a little bit more user-friendly, we could also stick in the cout statement a little message that says the sum is, and then just have sum right here. And the cout statements work from left to right. So this is going to happen first. It's going to say print the sum is, and then it's going to print the variable. Hopefully that makes sense, and let me know if it doesn't. And we can run it. The sum is 15. All right, that looks a lot better. Okay, so now we're going to compute the difference. And this time I want to do it in the cout statement. So this is option 1 right here. So in chat, write, how would you compute the difference of A and B just in a cout statement? There we go, A minus B. And how this is going to work is you're going to say cout, and then between these insertion operators is where the stuff that you're wanting to send to the console happens. So A minus B is an expression. So we're going to say A minus B. And then we can put some more insertion operators because endl is separate than A minus B. That's why they're divided up like that, because endl is telling it something completely different. This is referring to the subtraction operation, and endl is referring to an end line. That's why those things are separated like that. All right, so A minus B end line, and we could recompile. Okay, the sum is 15 and the difference is -3. I'm going to throw in a little statement here that explains what's happening. Alrighty, and save that. Okay, next we are going to do the product, and this time I'm going to do it again with the first method, the longer one, but we would actually store it. So I'm going to say int prod is going to be, what's the next line? So I created a variable. How do I assign the product to it? So we say product prod is going to be assigned with A times B, like that. Okay. And when we do an assignment statement, what's actually happening here is what is on the right side is going to get assigned to whatever's on the left side. So this statement right here, A times B is assigned to prod, is invalid. And you can see it's actually telling me this as well. And the reason is we have to assign to a variable, not an expression. A times B is an expression. And we're assigning from right to left. So whatever is the value of prod, it's going to try to assign to A times B, and that's not valid. Just wanted to clear that up real quick, if anyone was wondering. All right, and now we have a variable prod, which is going to have the value of a times b, and then we're going to just print that. Alrighty, and finally the quotient, and this one I'm going to just write it in the cout statement again. Probably bad practice to do it interchangeably like this. You'd probably want to stick to one method, but I wanted to show you guys both ways. So cout is, and this would be a divided by b. And you're actually notice something a little bit weird with this statement when we run it. All right, so here we go. I'm going to save this. So now we took input for A, we took input for B, then we added A and B and outputted it. We outputted A minus B, we outputted the product, and we outputted the difference. So if everything functions correctly, we should expect to see our finished calculator right now. All right, no errors, that's good. And now we run it. It asks for a number, 8, and I'll give it 3. All right, so we have the sum is 11. That works. The difference is 5, correct? Product is 24. And this is the quotient, not the difference. There we go. We said 8 and 3. Okay, there we go. That's better. The quotient is 2. And this is the thing that I was talking about with integer division. So if we were to do this on a calculator, 8 divided by 3, that would be 2.66666 going on for infinity. However, we mentioned that A and B were ints. And that means that it's going to perform the integer division, which means that it's going to divide A by B. And then whatever port was supposed to be a decimal, it's going to just cut it off. It's called truncating. And this can lead to accuracy errors in your calculations. So you got to make sure that if you are wanting that decimal to be included, that A and B or your numbers that you are dividing are not ints. So how do you think I could change this so I could see the decimals? Make it a little bit more accurate.
Turn it into a double.
Nail it. All right, so I want to do floating point division. And this is where we can get decimals. So when we have a decimal number, we store it in a double. Kind of makes sense with if you're having trouble with the decimal, D, and then double, they both start with D. So that's how you can remember it. So double A and double B. All right, anything else that we have to change, or do you think we're good to go? I think we should be good to go for now. All right, so we're gonna compile, everything's fine, no errors. Enter number 8 and 3. Uh-oh, I didn't save. Sorry about that. There we go, 8, 3. Okay, there we go, that's better. All right, so the sum is still 11, difference is still 5, product is 24, and now we have the quotient is 2.66667. And it rounded it for us because otherwise this would go on for infinity and that would take up way too much memory. All right, so any questions on the calculator or doing basic arithmetic in C++? This is definitely going to come up later in the course. You're going to be doing a lot of adding, subtracting, multiplying, dividing, all this stuff. All righty. If not, this program will be available on the Google Doc for SI, and you guys can mess around with that a bit more. We don't have much time left, but I can start to introduce you guys to the additional math functions that are in CMath. So someone said that we should include CMath for a calculator, and this is a fantastic idea because CMath can make our calculator a lot more advanced. Before, we only had really 5 operators. We had multiplication, division, subtraction, and modulo. I feel like I'm forgetting one, but we had the 5. And but we can have additional math functions using this library called CMath, and this just gives more things that we can do with the language. And there's a whole list of them. This is just a few. And I have this helpful little chart here if you're ever wanting to do some of these mathematical operations. You can see how to format it for CMath, but we'll talk about the most common three. We'll start to talk about the most common three today. These are the ones that you'll be using in the course. The more advanced ones, I don't think you'll see, but they're there if you ever want to use them. All right, so exponents, very, very useful if you want to raise a number to a power. So to write this in C++, you could write your variable multiplied by itself, multiplied by itself, multiplied by itself, multiplied by itself, however many times you need to do that. Or you could use this function called pow. And this is part of the CMath library. And how it works is you write the word pow, and then you do parentheses. And the first part of the parentheses is going to the base. So if we had 2 to the third, like that, 2 is your base. And then 3 is your power. So if I wanted to make this calculation, I would write pow. And then base would be 2 to the power of 3. So it's always base first, then power. And this little expression right here will result in whatever the value of 2 times 3 is. I mean, 2 to the power of 3 is. So this would all result in the value of 8. And then, of course, you could do different numbers. We could say pow, let's see, 3 to the second. This would just be 9. And you could do this with whatever numbers you want. All right, so that is pow. And now square roots are also very important. We're going to use those tomorrow when we create our quadratic formula calculator. And to do a square root, you just write SQRT, and then whatever number you want to square root. So this is the same thing. So of, I don't know, 2 is the same exact thing as square root of 2. Okay. And the very last one that's going to be important is absolute values. And absolute value is basically just the positive of whatever number is in the parentheses. So you'd write fabs, and then the number in the parentheses is going to be whatever number you want to get the absolute value of. So we could say fabs of 9 is the exact same thing as 9 absolute value. And this would result in just the value of 9. So these aren't too bad. The important thing to remember is even though there's all these words here, in the end, they calculate a value and that's what they result in. Any questions on these three? Because these are going to be the ones that you guys are using a lot. And then the additional ones are all right here. And there's a bunch here and you can look at the examples to see how to use them. In addition, on your textbook, let's bring that up real quick. Textbook. Your Zybook textbook. On chapter 2, it's a little bit ahead, but you have a lot more information on arithmetic and math expressions using C++. And I believe that all of the CMath stuff is in here as well, using math functions. There we go. So it explains how to use the square root function. And see, here's the 3 that I just talked about. So a little bit more information on those guys, along with the charts of all of them, and you'll be able to practice using these a bunch. So I know Steve hasn't assigned this to you yet, but if you do want to look ahead at the math stuff, it's all right here, 2.9. And it has, I guess I'll go a little bit over the textbook since we have a little extra time. So if you haven't used Zybooks before, basically what you're going to be doing every week is you're going to be reading through this interactive textbook. And it will introduce you to a topic first. And there's going to be these participation activities. And they're very interactive, which is nice for programming because it's not something that you can just listen to Steve or I talk about and expect to actually get down. To learn programming, you have to physically sit down and program. And this is what that book is going to help you out with. So it's going to teach you a concept give you a little description on it, maybe some interactive graphics, and then you will be answering some multiple choice questions on it. And don't worry about getting these right or wrong at first. Of course, like try to get them right. But if you get it wrong, it's not going to affect your grade as long as you just go in and click the correct answer. So it says incorrect. It is a valid assignment statement. And then I would just go in and click the correct one. And it's going to give me a little bit of feedback. Then I'll just go through all of those. And there's somewhere to type in the boxes. In addition, that's like all multiple choice stuff. There are also ones where you actually have to write small programs, and these are generally at the bottom of a section. And what you're going to do is it gives you some instructions, and it's going to say compute z is assigned with x times y. And it gives you an example. If the input is this, then the output is that. So, you know what, let's do one of these while you're here. Okay, so we are going to start the activity, and we can look at the program here. So we can see that they have already included IOStream for us. They've included CMath, and they've also included IOmanip. It's another library which allows for manipulation of outputs. So we can see that there's already 3 variables, x, y, and z. It took input for x and input for y. And now it's saying that we need to put some code right here. If you notice, when I type up here, it doesn't do anything. So it's very specific of where you got to type. So we're going to delete the comment. And how can we compute this in programming? What do you guys think? So, you know, on line 14, we're going to need to say z is assigned with the square root of x times y. What could I write here? So we're just writing one line of code here. Just a little short line to get some practice. So I'll do this one for you guys. All right, so we say that z, we have a variable z, so let's use that. Z is going to be assigned with the value of the square root of x times y. So which function did square root can be assigned with? Well, it's the one that's titled sqrt. It's an abbreviation of square root. And what happens is in the parentheses is going to be what you want the square root of. So we want the square root of x times y. And remember how parentheses function. Whatever happens in the parentheses happens first. So we have a parenthesis here anyways, which means that it's going to do this calculation first. So we'll do x times y and end it with an ending parenthesis. This is the same thing as this, right? Just a square root. And whatever is in the parentheses, it's what's going to find the square root of, and we add a semicolon after the end of all C++ statements, and then we'd press check. It might take a little bit, but it's going to do some tests on the program that you just wrote. And eventually, one day, it's going to tell us that, hey, I did test with this output and your output was correct. I did test with this and your output was correct. And if you get all of them correct, congratulations, you did it. And if not, you can go back and fix it. And you can just keep running this until you get the desired output. And all of those attempts will not affect your grade. So don't worry too much about that. And Zybooks questions are ones that you can always ask me or Steve. I've read through Zybooks at least 4 times by now. So any Zybooks problems that you're having and want a little assistance with, definitely ask me and I'll be happy to help you out. All right, so I think that is going to be it for today. Tomorrow, we'll talk a bit more about the functions in CMath because we didn't cover them very much. We'll do a program which will calculate the quadratic formula, and as well as explore a little bit of decision making using if and else statements. So I think that's all for today, unless you guys have any other questions.
Thank you, Stephanie.
You're welcome. Thank you so much for joining.
Have a good night.
You too.